In the last video, we talked about electron domains and what they are. We also talked about how to determine the number of electron domains that a central atom has. When we're talking about the shape of molecules, there are two types of geometry we tend to talk about. The first is molecular geometry. This is what we usually think of when we think about the shapes of molecules, the various angles between the different bonds in the molecule, or how a molecule is bent. The second type of geometry is the electron geometry. Electron geometry tells us where electron domains are relative to each other and how the domains are arranged around a central atom. Electron geometry is important because it determines the molecular geometry. In this video, we will focus on electron geometry, and we'll get to molecular geometry in the next video. Recall that electron domains include areas of electron density, including bonding regions and lone pair electrons. Electron domains repel each other because they're negatively charged. They want to be as far apart from each other as possible, and they take on shapes that will let them do that. Each of these shapes has characteristic bond angles, angles that occur between the different domains as the domains repel each other. Knowing about the electron geometries helps us make sense of why certain molecules look the way they do. For example, the shape of a water molecule is bent. What makes it bent? Well, knowing the electron geometry of the water molecule helps explain this. In this course, we will be dealing with 5 basic electron geometry shapes. For electron geometries, the main thing that matters is the steric number, or number of electron domains attached to the atom you are interested in. It doesn't matter if it's a single bond, or double bond, or triple bond, or a lone pair. It doesn't even matter if one of the electron densities has a bunch of other atoms attached to it. When we think of electron geometries, all of these regions of electron density count. When we think about electron geometry, we look at one atom at a time, even if there are many atoms in the molecule. Now let's talk about the 5 shapes. We'll use this simulation from PhET to help us, and I encourage you to go to the molecule shape simulation at phet.colorado.edu and play with this yourself. The first shape we'll look at is linear. Linear electron geometries have 2 electron domains. The bond angle, or angle that is formed between the different domains, is always 180 degrees. In this example, we have 2 double bonds, but each of these counts as only 1 electron domain. The second shape is trigonal planar. Trigonal planar geometries have 3 electron domains. They form a triangle, and the angle between each domain is 120 degrees. It doesn't matter if you have single bonds or double bonds or lone pairs, or if it's attached to an atom with other atoms on it. If it has 3 electron domains, the electron geometry will be trigonal planar. The third shape is tetrahedral. Tetrahedral geometries have 4 electron domains, and the angles between the domains are about 109.5 degrees. It doesn't matter what the domains are. As long as there are 4 of them, the electron geometry will be tetrahedral. All of these atoms have 4 domains around them, so their electron geometry is tetrahedral. The fourth shape is trigonal bipyramidal. Trigonal bipyramidal electron geometries have 5 electron domains. The bond angles are either 120 degrees or 90 degrees depending on where you are on the shape. It will be easier to see once you build some of these yourselves. If you draw lines between the bonded atoms or the ends of the domain, you'd get a shape that looks like 2 3-sided pyramids that are stacked on top of each other like this. All of these molecules have trigonal bipyramidal electron geometries, even though the types of domains on them are different. Octahedral electron geometries have 6 electron domains. All the bond angles are 90 degrees. If you were to draw lines between the tips of the domains, you would get an octahedral shape, like having two square pyramids stacked on top of each other. Again, it doesn't matter what the domains are. If you have a steric number of 6 or 6 domains, the electron geometry will be octahedral. So, let's review. Electron geometries are the shapes that are formed by the areas of electron density, or electron domains, that surround a central atom. It doesn't matter if these domains involve lone pairs or double or single bonds. The only thing that counts here is how many electron domains there are, not what they are. Electron geometries are important because they will determine the molecular geometry. We'll look at that in the next video.